I'm going to share some of our ratio work. We are using mostly Making Math Meaningful as our source book, and this is going to come up a little later. She does have somewhat of a grasp, but it's going to come up later in geometry and some in algebra, and I just wanted to have this seed planted so there's some connection for later when we get there. Okay, so this is basically two things. We are using the rods, of course, and we are color coding, of course. So this is our A to B to C to D. So A to B is equal to C to D. What else do we know? And we're doing a little bit of play and exploring to find the answers here. So let me get a white background for this. This is not white, but it gives you a better idea. Here, we'll do it this way. So what I did was set up the ratio, and then we talked about if these are equal, if this is true, that A to B equals C to D, what else is true? And she already knows from other things, particularly fractions, and we've talked about fractions and ratios and how they're alike and how they're different, but how we can cross multiply, and they stay equal. So 2 times 6 is 12, and 3 times 4 is 12. So if you are not familiar with the rods, initially for multiplication, let me grab some other 2's here. You start out end to end, right? And eventually, we're actually, for this one, doing 12. So what is that? 2, 3, 4, 5, 6. That would be 12 right there. You can see that 6 of 2's, or 6 times 2, is the same as 12. So if we organize them in this direction here, which is area model multiplication, then we have 2 on this side and 6 on this side. So that still gives us 12, and we can see that that is the same as 2 6's. So when you are using the rods to explore higher level multiplication or factoring and so forth, you can make crosses, and these are our crosses. So we figured out that 2 to 3 equals 4 to 6, that when we cross multiply, those remain equal, and the 12 is equal to the 12. Okay, what else do we know from this? Another thing that we know is if we look at the reciprocals, they are also equal. 3 to 2 is the same as 6 to 4. And those we already have under our belt because of fractions, but what we don't have under our belt is this last one here, which is going to come into play with geometry, which means here's our original ratios, 2 to 3, 4 to 6. It means that we can take the antecedent. So when you're looking at ratios up here, A to B, the first number in the ratio is called the antecedent, and the second number is called the consequent. I know that you can have more than 2 numbers in a ratio, and I do not know what the other numbers are, but this is in a 2-number ratio. This is the antecedent, and the second one is the consequent, and these correspond to the numerator and denominator in a fraction, but fractions act like ratios, but they are different than ratios. So when we know that A to B equals B to C, we can take the antecedent from both of them and add it to the corresponding consequence, and our ratios remain equal. So 2 to 5 is the same as 4 to 10. And this is one of the reasons that we are using the rods, is because you can see that those ratios stay the same. Conversely, you can take the consequences of each ratio and add it to the antecedent, and it remains the same. And this makes sense because our reciprocals are also equal. So anyway, this is our main lesson page. This was work from last week, and we are just now doing our main lesson page for that. It's color-coded. So this is our A to B, red to green, and C to D. It makes it easier to keep up with what we're actually looking at and doing.